today's notes. Fraction simplification part 1. We do have a part 2. Stay tuned for in-class notes. Anyway, so our learning target is I can add and subtract fractions as well as reduce them. Let's move on and jump on to example 1. So here I have 1/5 plus 1/6. In order to add two fractions or subtract them, we want to make sure our denominators are the same. So here you see a 5 and a 6. They are not the same. That means we gotta do some math. Anyways, what I'm going to do is multiply this fraction right here by 6 over 6 and this one by 5 over 5. You'll see that when I do that, I'll end up having a common denominator. So that's what I just did. Usually it's by multiplying by the other fraction's denominator. That's where the 5 came from. So then 1 times 6 is 6, 5 times 6 is 30, 1 times 5 is 5, 6 times 5 is 30. As you can see, you get a 30 here in the denominator, and on the top you get 6 and 5. Once our denominators are the same, you can go ahead and add the numerators. 6 plus 5 is 11. And that's it. 11 over 30. And that's it. Basically, you can't cancel out anything from 11 and 30. You are done. These examples, and this is the basic example, but these examples are going to move up in difficulty. Here's example 2. As I mentioned, they're going to move up in difficulty. So here we go. So here you're subtracting two fractions. For this one, you're going to multiply the top and bottom by 3, the denominator of this one. And for this fraction, you're going to multiply the top and bottom by x, the denominator of your other fraction, like so. Because again, as you'll see, when I do this, I get a common denominator and I could add my fractions. So 2 times 3 is going to give me 6, 5 times x is 5x, 3 times x is 3x, x times 3 is again 3x. It doesn't matter if the x was in front. So this is what I end up getting once I multiply everything. Alright, so now that the denominators are the same, you can combine the numerators. The numerator is just going to become 6 minus 5x all over 3x, the common denominator. And you are done, because 6 and 5x are not like terms, therefore you cannot combine them. And by the way, no, you can't cancel out these x's right here. You can't, because this x is trapped in the 6 minus 5x. You can't just cancel it. This right here is by itself. If the x up here were by itself, then you could cancel, but don't worry about that. This one, we're going to just leave it. Example 3. Here we go. Let's go ahead and follow our usual technique. What I'm going to do, and by the way, there is another way to do this problem. You could go ahead and do this problem in your own way if you desire, but I'm going to show it in the way I've been doing it to promote consistency and to diffuse any more confusion. So this is what I've been doing, which is basically multiplying by the other fraction's denominator, as you can see here, just multiplying top and bottom. Again, this is going to lead us to having a common denominator. So this is going to become 3x squared. This is going to become 2x cubed. This right here, x to the third power times x squared. Usually when you have the same bases, you add your exponent. So the bottom is going to become x to the fifth. Now, I'm going to pause here because I don't remember putting x to the fifth. So wait 1 second. I'm going to correct that. Oh man, it's big. So you guys know, these PowerPoints take me a while to do. Look how hard it is just to, yeah. Good thing we're fixing this now, so that you can skip the video if you're still waiting. So let me just restart this. Alright, we are back in business. Alright, so then when I multiply this, I get that, and this combined gives me x to the fifth. Now that my denominators are the same, I'm going to go ahead and combine my numerators. Awesome. 3x squared plus 2x cubed, because they are not like terms, we cannot combine them, and the bottom is just x to the fifth. Now, in the future, we will talk about factoring out an x squared from the top and being able to cancel with the bottom. Right now, no, you cannot cancel anything right here. Because again, these x's up here are trapped with this plus sign. So, this is our answer. Now let's go to the last and more complex example. When you get to the task, I would like you to make sure to use your notes because you want to reference your notes always. Alright, so as you can see, this is our complex example, but we're going to be following the same steps that we've been doing. Here's our first step. Yep, multiplying by the other fraction's denominator. Good. Now, we've got to make sure that we distribute because there are parentheses here. That means x has to be multiplied by the whole x plus 5 denominator. 2 has to be multiplied by the whole x plus 1 denominator. Let me distribute in my next step. See how this became x squared plus 5x right here. This became 2x plus 2 over here. And then our bottom, you could just leave them like that. That's fine. You don't have to FOIL it. Honestly, it's fine. Alright, so I highlighted the minus sign as green for a specific reason because this minus sign means I'm subtracting this whole fraction. Therefore, this minus sign must distribute. So we go ahead and we distribute that, and then we'll be able to combine like terms. So then we have 5x minus 2x, which is going to give you 3x. And then you fully have combined your like terms in the numerator, and you leave your denominator the same. So at this step, you can go ahead and FOIL the denominator if you'd like, but for me, that's fine. All I want you to do, and the goal of this, is if you can combine your fractions by using algebraic techniques here. So like I said, you can FOIL this, but this is fine as the answer for me. We're good. Oh. Anyways, the end of notes.